Algebra 1, Unit 3, Linear Functions, Equations, and Inequalities, Module 5, Linear Functions. Lesson 3, Interpreting Rate of Change and Slope. Well, let's start. So here we go. 5.3, Interpreting Rate of Change and Slope. Spoiler alert, they're one and the same thing, right? So essential question is, what is a functional notation, and how can you use functional notation to model real world situation? I think context in this case, it's a linear function. And anyways, let's get going. So we need to determine the rate of change. You know what? I'm looking at this and that makes no sense to me. I think I might have copy pasted it, the wrong essential question. I apologize for that one, guys. Yeah, so sorry about that. So clearly, the essential question today is going to be understanding what what a rate of change is and how does it relate to a slope, right? So to determine the rate of change for a function, defined in terms of x and y, the rate of change over part of the domain of the function is the ratio that compares the change in y and change in x. So this right here is a slope. Slope is the rate of change. And the way we calculate the rate of change is change in y divided by change in x. And we call that rise over run. And you're going to see that term again on the next page. Okay. But before we continue, you might have seen this triangle. That's actually capital delta. So I'm going to put capital D delta. It just means change. It's a Greek letter. And we use certain Greek letters over and over again. And these are the ones that you should be very familiar with right here, guys. And let me change the color so it sort of stands out a bit, right? So these are the common Greek letters. That's a pi. And circle with a diagonal line through it is phi. And then circle with a horizontal line right across the middle is theta, usually for angle. So these two are usually used for angle. And you guys should know pi already. And this triangle is capital delta. Okay? All right, guys. So we will be finding the rate of change, slope, for each time period using the table. So we have over here x. So it's the rate of change over the years, right? There's a number of years after 2000. So that's 2003, 2004, 2013, and so on and so forth, okay? And this right here is the x, and that will be the, what? Domain slash independent variable. Independent variable because almost always, there are exceptions, but at the high school level, it's pretty much always, right? But you never want to say never, and you never want to say always. You got to be very careful with those statements. So, almost always, time is domain or the independent variable. Okie dokie. And here, let's call that y as a dependent variable, as in cents. And it's not all that important what application this is for. I mean, this could be the, I don't know, the how much they charge per transaction for, I don't know, making a phone call or charging credit card, let's say, or ATM transaction fee. Although I'm sure those are much higher than this, right? All right. So from 2013 to 2004, what is my slope? Change in y over change in x, right? The way we would do that is subtract the difference of the two between these two. So we went from 3 to 4. So the difference is 1. But it's like 4 minus 3, right? But technically, it's actually 2004 minus 2003. Okay, 2004 minus 2003. And its y values are 37 and 37. So there's no change. So that is 0. But keep in mind, guys, that was 0 cents per year. Okay? So that was, so it didn't change at all, right? Whatever it is that you were charging. From 2004 to 2006, the 2 years has passed. So denominator has to be 2. You got that because, that's right, 2006 minus 2004. In 2006, you're charging 39 cents. In 2004, you guys want to be very consistent over here, right? Because 2006, you charged 39. That goes first. And then we have 2004, and that goes with 37, right? And that goes 2, which is 1 cent per year. That's how much it changed, right? And changing y and changing x from 2006 to 2008, that's 2 years. So we know that that's like 2008 minus 2006, right? 42 minus, yep, 39, that's 3. That's 1.5 cents change on average over a year for the period of 2 years, right? That's how much it changed. So slope changes tells you the average rate of change in this case, right? The rate, or you could say rate of change over unit time, which is in this case 1 year. We do the same thing for 2008 and 2013. I believe that's 5 years, right? Yep, it is. So that's 2013 minus 2008. And how much did the y value change? That's a difference of 4. So you gotta show where you got it. So 46 minus 42, that is 0.8 cents per year. So it looks like this. So let's take a look at this, guys. Okay, let's just graph this thing. Okay, so all right, that's good enough. Okay, that size is pretty good size. Let's make a copy, paste. Let's do it again. Copy, paste. There you go. The first one, 2003 right here, had cost of 37 cents, which should be right between 36 and 38 right there. Was that good? Yeah, it was. And in 2004, same. Okay. What is in 2006 is 39, which went up about here between 38 and 40. And what is 2008 is 42 right there. And what do we have for 2013 is 46. 13 is over here. 46 is right here. Let's get rid of these now. Let's connect to see what it looks like, right? So that goes from here to, oops, too thick. Let's make it a little thinner. From here to here. There you go. Okay. The slope that we found over here from 2003 to 2004, it does no increase. It increased 0 cents per year. And from 2004 to 2006, which is here, that indicates that 1 cent has increased. 2006 to 2008 is 1.5. Notice that it's a little steeper over here than compared to this. Yeah. So it was rising faster, right? The cost of postage. Sorry, I didn't read the question. It's a postage stamp, right? So yeah, for 2 years in a row, it was rising at 1.5 cents per year. And then for the next 5 years, it's 0.8. See that? That's, if I go straight, oopsie. If I go straight, it looks like this. Oopsie. You know what? Let me just do it this way. There you go. See that? I just extended the line all the way through using green. See that? This is a little less less steep, right? Because it's 0.8 cents per year. It's slightly less increase from 2004 to 2006. Had this gone straight over here compared to this, yeah. So the slope tells you how fast or how slowly something rises, right? Higher the slope, steeper it is. And then this is less steep with 0.8. That's the slope or rate of change. And over here, there's no change at all. Okie dokie. All right, guys. Let's move on to the next set of questions. Okay. Okay. And it should be, I think, it's over here. Oh, there you go. Okay, you may have some writing to do. The rate of change for the linear function can be calculated using what's called rise over run. And from what we've done earlier, the rise over here is the change in y, and the run is the change in x, right? The rise is the difference in y value. It literally tells you the difference in y value, which means that it is change in y. The run is difference in x value of 2 points in a line with change in x. So change in y, how do you find that? y2 minus y1. Subscript means the second one minus the first one. Or you could swap them around. y1 minus y2. The first y minus the second y. It really doesn't matter. And this one may be x2 minus x1. If you prefer to swap these two, make sure you swap both of them. Okay? Yep, the way you calculate has to be very, very consistent. And then, so this right here would be the rise, which is the change in x. Right here would be the run. Oops, rise is y. And that'll be change in x. Okie dokie. All right, so what this says right here, the slope of the line is the ratio of the rise to run. So slope is rise over run, or simply change in y over change in x. Yeah. So these are very similar ideas, right? So the slope is what we mentioned earlier, rate of change. That's what that is. Rise over run, difference in y values, or change in y or change in x. So knowing that, what is my slope over here, guys? Slope. Oh, by the way, the common notation that we have for slope is m. Y equals mx plus b, right? So m, which is change in y, change in x. Sometimes it's hard to count, so you know what you should do? It's just subtract. Remember, this is y2 minus y1 over x2 minus x1, right? So you got, what are the two y values? 4 and a 1. You subtract them. 4 and 1. The difference of 4 and 1. And you have to be consistent with the top minus the bottom. So we're going to go top minus the bottom, which will be 3 over 2. So difference of 3 and 2. That's 3 over 1. So my slope over here is 3. Okay. How about for part B? And the slope that we have is over here, right? So that is the change in y. This part is the change in x. So how do you find them? Well, once again, slope is change in y and change in x. Just get in the habit of writing that out until it becomes like really part of you, right? Oopsie. And then there's y2 minus y1 divided by x2 minus x1. So what are my two y values here? That's a 3 and a 0, right? So I'm going from left to right, so you have to be very consistent about that. So that's 3 minus 0. And then from left to right, the x values are these two. Right, negative 2 minus 1, so that's 3 over negative 3, so my slope is negative 1. By the way, if slope is negative from left to right, it goes down. And slope is positive, therefore from left to right, it goes up. Okay, higher the number, higher the magnitude of the number, steeper it is. If it goes to 1, it goes like this. And if it goes to 0, it sort of flattens out, and so on and so forth. Okie doke. All right, guys. All right, what is up next? Ooh, last one more page, guys. So the slope formula, right, that we have is slope formula. For the slope of the line is a ratio of the difference in y values to the difference in x value. I think we said that about 10 times already, right? Yeah, learn by repetition, guys. By the way, the subscript right here, right? It means that it's the first x, and that here means it is the first y, and that is the second x, and that means that is the second y. It's just basically telling you, right? So it's the second y minus the first y divided by the second x minus second 1. It's a very mathy way of saying you should be consistent in how you subtract. Okay? All right. So this will be like the first pair because it's 1, right? First xy coordinate. This is a second xy coordinate. And once again, that is called subscript. Okay, if you're not familiar with subscripts, it looks like this. Let us say that you have a letter A. If you write it over here, that's called a sub under script, that's writing. If you put it over here a little bit on the upper right hand corner, that is super above, superscript, writing above. Okay, dokie, guys. So subscript tells you it's the first one, the second one, or the third one. Okay. All right. So it's asking you to find the slope of each line passing through given points using slope formula. Describe the slope as positive, negative, or 0, right? So positive is something that goes from left to right, up. Negative is left to right going down. 0 is horizontal. Oopsie, let me just zoom in a little bit, okay? So it is horizontal like this, or horizontal. Undefined is vertical. It's up and down. So this is a vertical line. Okay. So only thing out of the four, only thing that does not have a value, undefined, is the only one that doesn't have a value. Okay. Okay. So how do I calculate the slope over here? So once again, the slope over here, m, is change in y and change in x. So let's go right minus left, okay? So that is 3 minus 1. Remember, we are looking for the difference of the two, right? So we got the x values is 2 and negative 2. So that is 4 over 4. My slope here is 1. Yeah, I mean, it's greater than 0, right? So it is positive. Okie doke. Let me just put that here somewhere like this. Slightly smaller. Okay, that's good. Okay. So from left to right, it's going up. And when something is 1, it's about 45 degrees, guys. That's this way. And if it's bigger than 1, it's pretty steep. Between 0 and 1, less steep. Okay. Now, that was using graph. How about using tables? Okay. So what's going on? Well, in terms of the change in x, it's all 2, isn't it? Remember we did this before? That's a 0. So we need to look at the matching ones over here. So this on the bottom, these are change in y. These are change in x, right? So change in y and change in x. Oh my. That's 2 over 0, okay? So in method 1 that I'm just showing you right now, just using how much it increased per, and every single time change in y and change in x, it's this divided by this, this divided by this, this divided by this. They're all the same, right? So that's 2 over 0, which is undefined. If you wanted to, you could have actually done the calculation without what I did, just by seeing how much it adds. You could look at the difference of the two. Look at the y values. See these two? That is 4 minus 2 over 3 minus 3, which is 2 over 0. And you could tell, if I did that, that would be 6 minus 4, which is 2, divided by 0. Okay? So here, slope is undefined, right? Maybe I should have said m over here. Oopsie, m. And the slope over here is undefined, which means that it is a vertical line. Okay? All right, guys. Let's get to the next two, shall we? Interpreting slope. Example 3. Find and interpret the slope for each real world situation. Part A. Part A says graph. The graph shows the relationship between person's age and his or her estimated heart rate. I don't know if this is true because I'm in my 50s right here, and I guess this was 150, right? Yeah. Well, when I ride my mountain bike, I go regularly above 180, like sometimes around 190, right? So, anyways, so I think what they say is your maximum heart rate is, I believe, if I'm not mistaken, 220 minus your age. So if you're 50 years old, subtract 50, that's 170. So this one is a little bit off, actually. Okay. So they're not using the what I read in the article. All right, but it doesn't really matter. So let's say this is true. So using this graph, we could sort of estimate, right, what's going on. So the graph shows the relationship between the person's age and his or her estimated maximum heart rate. Okay, so what does that tell you? It says find and interpret. That two parts, guys. So let's find it first. Number one, let's find it. Slope is change in y and change in x. Y values I'm changing is 180 goes to 150. Subtract, when you're 20 years old, you're 180, minus when you're 50, you're 150. So that's 30 divided by negative 30, which is negative 1. So what does that tell you? So that's equal to basically negative 1 over 1, isn't it? Let me write a little neater. I'm not happy with that handwriting. It's worse than usual. Okay. So the age increases, right? So let's keep that positive. So the numerator is negative. So what that means is what? The average heart rate, the whole thing is called, the slope is called average heart rate, decreases by 1 for every year that you get older. Okie dokie. So each year you lose 1 heartbeat of maximum heart rate. Okie dokie. So according to this particular graph, when you're 80 years old, your maximum heart rate probably should not exceed 120. Yeah? Okay, I think we got the last one, guys. How did the plant y in centimeters for after x days is a linear relationship. So point 30 days. The height is 15 what? Centimeters? Yeah, centimeters. Right here, guys. 15 centimeters. And after 40 days is 25 centimeters, right? So how do you do the calculation? Well, let's do the basic picture right there. So this is 1, 2, 3, 4. That's a 30 and a 40, right? And this 15 and 25. So 1, 2, 3, 4, 5. So that's 25. And for 30 is 15. 1, 2, 3. About here. So I guess this kind of looks like this, guys. Yeah. Okay. But you don't have to extend it out all the way through. Okay. Just do that part. So according to number 1, find. Sorry, that should have been 2 right there. Okay. Number 1, let's find the slope. Slope is change in y over change in x, right? And my 2y values, remember y2 minus y1. You don't have to write that out, but it helps if you do. 25 minus 15. I generally choose large minus small because it's more convenient. Okay. And then that just happens to be the right minus the left, right? So let's do the same thing for the x's. x2 minus x1. So it's right minus the left, which is 40 minus 30. So it's 10 over 10, which is 1 over 1, which is 1. So remember, we know that this is centimeters, the numerator, denominator is what? Per day. So it is increasing 1 inch per 1 day. Okay, so here's the interpretation, guys, right? The height of the plant, of this plant, increases, or it's up by, increases by 1 centimeter per day, or for each day. Any one of them would have been fine. Okie doke. All right, guys, that is it for me. Okay, so why don't you guys go ahead and try your turn on your notebook that's been provided for you guys, and pause the video. Okay, here are the answers. Let me zoom in for you. 7 and 9 answers are right there, as you could see. And answers for 10, 11, 12. Okay, guys, once again, this is what we went over in class. So if you have any questions or concerns, make sure you stop by the tutorial. Okay, I shall see you later.